to the GBF Transformational Antennas webinar, End of the Parabolic Paradigm, sponsored by Kenmars, for which thank you very much indeed to them. It's an area of great interest, and hopefully we'll be learning something. My name is Jeremy Rose. I'm a partner at Comsys in London. You probably know we do satellite communications consulting work. And we have a excellent set of speakers in alphabetical order. There's Keith Edenfield, who's the CTO of AVL Technologies, Bill Marks, who's Chief Strategy Officer at Kymeta, Alvaro Sanchez, who's CEO of Integrasys, and Eset Sibai, who is the COO and CFO of Alcan Systems. So, flat plate antennas, they've been the holy grail of antennas for satellites since I started Comsys in 1982. At the time, the reason why they were so interesting was because of the hot bird concept. SES were charging a lot more money for their transponders because unless you had a steerable antenna, which was a lot more expensive, the satellite which had most channels on was the one that the consumer antenna was pointed at, and that was the one that had the holy grail hot bird concept of the neighborhood of all of the channels. So I think we all know it's difficult to try and figure out what the knowledge level of the attendees is. So hopefully I won't be too avuncular and going on the other direction too far over to the technical side. Parabolic antenna, you probably know it's a dish. There is a feed at the focal point. It could be there's a receive feed and a transmit feed, and it's steerable. Sometimes if you have motors to steer it, it's physically steerable, but it's not electronically steerable. If you want to steer it, you actually have to move the thing. There we go. Let me just come off screen share. So you want to steer the antenna, you have to actually move the antenna physically. So about 30 years ago, the idea of a consumer flat plate antenna or conformal antenna or electronically steerable antenna came along. They've been around for ages. The good news is they've been around for 50 years. The bad news is that you put them on fighter aircraft and they cost $500,000 or so. So making them for $500,000, $50,000 is really easy. Making them for a consumer application is much more complex. How do they work? I think we're going to hear that from some of our panelists at least. But there's basically lots and lots of antenna elements, say 1,000 by 1,000 antenna elements, and each one in a flat plate or a conformal plate, but probably for our purposes a flat plate antenna. It's each antenna element generating a signal or receiving a signal, and then the way you manipulate the steerability is to rather cleverly make sure that the timing on each element is correlated correctly. So how do we get it down from $50,000 to $500? And that's where the complex stuff comes in, which I'm sure our speakers will talk about. So we have Keith Edenfield from we've discussed this already, haven't we? I've introduced the panelists. Keith from AVL, Bill Marks from Kymeta, Alvaro Sanchez from Integrasys, and Eset Sibai from Alcan. There are 3 manufacturers of flat antennas, and Alvaro is working for Integrasys. He's the CEO there, and they make software which monitors satellite signals and network design, and will be used in setup of these antennas. So there's 3 categories of these flat antennas. There's the consumer type, there's the enterprise type, and then there's the mobile that goes on ships and yachts and aircraft, and they all have their different characteristics and limitations, and hopefully those will be some of the questions that we'll deal with. So let me go through, start with the first question in alphabetical order, perhaps. First of all, to Keith. The question really, what's the big advantage of the flat antenna over the parabolic antenna? I've talked about some of them, but what's your summary on that?
Well, of course, the big things are the aerodynamic nature, or conformal nature from the flat or conformal form factor would be important. And another application might be for small pack-up for portable antennas on the ground, like man packs. And then, of course, if it's a fully two-dimensional steered, electronically steered mechanism, there's no moving parts in it, so it can be extremely reliable and fast scanning for tracking applications.
So I'm getting the impression from that answer that you're not talking about the consumer antennas. You're talking more about the aeronautical, expensive, high-performance ones.
Correct. From AVL's perspective, as most people probably know, we're a large provider of parabolics, but we are keenly interested in what's coming, and we are investigating flat panels, but we would target probably higher end use cases, not consumers.
Bill Marks?
Sure. So I think firstly, I would say that we've got to understand that all flat panels are not considered equal. So they all have different advantages. From our perspective, obviously Keith is right. Form factor is important. They're lower profile, lighter weight. They fit onto more platforms. Secondly, the capabilities are much different than that of a mechanically steered gimbal dish from our perspective, and also from our perspective from other flat panels. So lower power consumption, no moving parts, very little heat generation. And I think the big thing for the future is the ability to form multi-beams to point at different constellations and create interoperability between GEO and LEO, and also do the handoffs, the make before break handoffs on LEO constellations. We've had antennas in the market for 2 years, and one of the big things is the installation and maintenance. Going back to what Keith said, no moving parts. We have had virtually no antennas break in the field, and installation is really simple. They're generally a contained unit, so the outdoor unit has all of the RF chain, including the modem, and it's easy to install. It's a one-button operation, so give it power, hit the button, sit back, and wait for it to connect to a satellite and commission and provision. And then finally, I think the exciting thing and why it gets all the buzz is just the new markets that are enabled by flat panel antennas. So we've seen our antennas our first generation antenna go onto trucks and cars and trains and buses and small vehicles and very remote locations. These are typically not platforms that can take a parabolic dish. So, we see the market growing substantially with the advent of these flat panel antennas.
So moving on to Alvaro, is this the end of the parabolic antenna, do you think?
I don't think so. We are a believer of flat panel antennas. However, we see that parabolic would remain relevant. For example, it will be long until flat panel antennas can replace parabolic antennas in maritime environment. So the maritime networks, there are many networks already deployed, and the gain in these networks of the antenna in the parabolic antenna scenario is large, and the gain in the flat panel antenna is smaller. So it is a form factor as well as the gain, which determines the throughput that finally the antenna will provide to the crew or to the passengers in that particular ship, or in that particular satellite, in that particular plane, or in that particular home or office. So we highly believe that flat panel antennas are complementary to parabolic antennas, and they will be a game changer for LEO and MEO. But however, parabolic will remain the standard for GEO communications in that regard, thanks to its gain that the flat panel antenna today doesn't have the same.
So do you think that the lack of gain that the flat antennas that you're saying is a problem now will solve itself in the next few years?
Maybe we can solve it. There are multiple problems for flat panel antennas, but also applications that doesn't care about those problems. So there will be applications that will be much better served by flat panel antennas, but other applications that will remain with parabolic antennas, depending on the requirement.
Okay, so Esat, what's the big deal with flat antennas?
Right. I mean, lot's been said, so I'll try to focus on the deltas of maybe what else we think is there. I mean, I think one big theme is movement. The parabolics, first of all, maybe start to say are excellent technology, and we should take our hats off to a technology that's been with us now for more than well, probably 70 years almost, or 60 years. Has worked superbly, and you know, is still an unsurpassable technology in terms of its abilities. The problem starts when you start having movement, either of the satellites or of the platform, and this is where parabolics with a motor underneath it just are ill-suited to meet the needs, particularly going forward. You need something which is, you know, if you're talking about an NGSO constellation, the satellites are moving. If you're on a mobile platform that's maritime or an automobile, as Bill had mentioned, then something's moving, and the parabolics with a motor underneath it are just ill-suited. Ill-suited because continuous motion of mechanical parts always raises the issue of maintenance. This is one problem, and there's a fail-safe problem as well. These things break down at the worst possible times, and so with the electronically steered antennas, there's no moving parts. It's all electronic. So think you know, computers and TVs, etc., which once you buy and you start using them, you know, 5 to 10 years of lifetime, no replacement required, no repair, you know, only exceptional situations. So I think this is one area, is this durability and you know, not having the need to service them. This is the first. And secondly, I think form factor is going to be very important going forward. In the past, where you were using this mostly for enterprise, having a big dish somewhere pointing at a geo satellite, that was fine. It was out of sight, nobody cared. The future is more about consumers using these things in their houses, in their cars, and also in their boats as well. And people don't necessarily want these big domes sitting, or two of them even sometimes sitting in their premises. They would prefer something which is flat, disappears from view, but does the job. This is what flat panel antennas are, and this is why they're such a big deal. They're going to be a huge enabler of the satellite's usage of the future. And so in that sense, we think that they're going to play a pivotal role in the increased usage of satellite services, as well as becoming a lot more mainstream than they have been in the past.
So are they going to take over on all sectors of the market, from the consumer to the 18-meter mega dish?
Absolutely not. I mean, I think the traditional playing field of the parabolic will stay. I mean, so gateway antennas, you know, 2.4 meters, 5, the larger ones, which are acting as sort of the gateways, those will probably remain. Anything which is fixed and geo, that doesn't really need replacing. So if you're pointing to, you know, the TV dish antenna that's getting its signal from a geo satellite, that you don't need to replace. You can, if you have some aesthetic qualms about the way it looks on your building. But once you point it, you know, for the next 10 years, you don't need to change it. So I think for existing use cases where we've mostly used these dish antennas, you don't need to replace them. And also in the future, these use cases will of course continue. But the point is that the future is all about data connectivity wherever you are, whenever you want it. And using NGSO satellite systems, or all these new ones that are coming. So O3b already up there, already you know, showing a great performance, and then you have all these new ones which are coming. For these new satellite constellations, you need a flat panel antenna because it has huge advantages over the parabolic end usages. So I would say it's an incremental one, but it's a major incremental one because the future is going to be so much bigger than the past was, and this is what the big deal is about the flat panel antennas.
So let me just go back to Bill and just follow up on one of those questions, if I may. Do you feel that the major market for the for flat antennas is going to be the mobile market or the consumer market? Bill, can you hear me?
I can hear you now. Sorry, you broke up. Could you repeat the question?
Yeah, I'm sorry. Apparently, I'm having a sound problem. Do you see the major market for these flat antennas being in the consumer area with OneWeb or any of the other NGSO constellations, or do you see it on the mobile aeronautical side of things? In other words, there are large numbers of low-cost antennas or a relatively small number of very expensive antennas.
Yeah, there's our focus is on mobility, specifically land mobility, because we think that's the sweet spot. We don't really think we have a path or desire to go after the consumer broadband terminals because our capabilities are much greater than are necessary for that. So, you see SpaceX building their own antenna for consumer broadband and others. But I think the real advantage of our particular flat panel antenna is around mobility. So we're totally focused on opening up those markets and enabling those markets because we think they're quite large. Obviously, the direct-to-home or consumer broadband is large as well, but it's not really our sweet spot. And you don't need as complicated of a device to do consumer broadband.
But that's true of Kymeta, but just generally looking at the industry in general, do you see the selling cheap being a greater size of market than the mega ones?
Yeah, so it's an my background, my entry into the satellite business was with DirecTV in the United States, and it was a direct-to-home provider, and we never could figure out how to make money on the hardware, frankly. So unless you're in the service business, it's going to be a very difficult business proposition to try to figure out how to make money selling the hardware to the direct-to-home or the consumer broadband companies because they're all about service, and their expectation is that the antenna will be a giveaway. So it's a challenging spot for where the industry is today to try to resolve because these things are complicated to make, and it's an expensive proposition to figure out the science and get it right. So we certainly are not going to start in direct to home. Potentially, the flat panel companies that you've referenced today will eventually get there, but it's not going to be for a while.
So Alvaro, you're involved in the installation, setup, and planning of antennas. Is this going to ruin your business? Are all of the antenna installers on the call now going to be shaking in their boots because I'm just going to get a package in Amazon and I slap it on the roof and it goes off and does its own thing and I don't need an installer at all?
No, actually, it brings an opportunity for us. At the end of the day, everybody wants an antenna that is like an iPhone. It roams from one place to another. You just turn it on and it's on, and you have to do even no touch, no one touch. So we develop an API for antennas to integrate, and this way they can provision, commission, and do all the process without even a single touch. So it is an opportunity. We just filed a new US patent on this technology in order to make the antenna absolutely no touch and be able to start service, whether it's in GEO, MEO, or LEO, without given touch. So it is pretty unique technology. But answering just the question right before, there will not be any end user application such as direct to home until LEO constellation that doesn't invest heavily in flat panel antennas like SpaceX is doing, because at the end of the day, you need a huge investment in technology and then deliver for getting the revenue from the LEO constellations as well, which have great investment behind. So in that way, only they will benefit from LEO thanks to those little small antennas, very, very cheap, but very expensive to develop. So it is curious how cheap they will be, but how expensive to develop they are. But as the constellations are very expensive as well, that will drive the numbers for flat panel antennas. It will be a combination between new satellites and new antennas.
So, Keith, is that true in your sector as well, in terms of the products that you're producing?
Well, I believe that kind of going back to the earlier question, the performance of a space-fed reflector antenna is always going to be the most efficient use of aperture. So we believe that the initial flat panel applications will all be sub 1 meter sizes, just due to the initial cost and complexity, which may come down in the future. But I did want to point out, even for sub 1 meter sizes, if you look at the efficiency and compare the losses in a space-fed reflector to any flat panel, regardless of the approach, they're going to have, up to several dB more loss in the feed network than the flat panel. So even in small antennas below 1 meter, we think there will still be some room for parabolics.
Right.
Does that answer your question?
Yeah, I'm just looking at questions that have come in from the attendees. There's a question relating, Alvaro, to your comment about gain, with flat antennas having less gain than parabolic. How will that change the electronics on the user terminals? Are they going to need bigger bucks, and what other changes might there be?
So basically, the gain in the flat panel antenna is not stable. If you have a look angle, it changes. Here we have the maximum gain, and here we will have smaller gains. So one thing is that it's not stable. So as higher in the north hemisphere and lower in the southern hemisphere, you will have a little less throughput. Gain because the look angle would be different, and I saw in the questions about 2.4 meter antennas. For the time being, I don't see a flat panel antenna of 2.4 meters. So I don't know when it will happen, but it will be later and not in the coming years. So in that regard, we are looking that antennas have less gain. Let's say from if you use a parabolic of 0.6, it will be equivalent to a 0.8 or to a 1 meter antenna in the other way. So parabolic 0.6, 1 meter flat, or 0.8 flat. It depends, but it depends manufacturer, depends the efficiency, depends the look angle. So it is more complex in that regard.
Right. I mean, typically, we hear about the problems of low elevation angles for flat antennas. Is that a continuing problem, or is that something which is soluble? Perhaps that's, well, let's just put that to ESAT. In terms of low elevation angles, is that always going to be something, as we say in the UK, a bit dodgy?
Today is physics. Maybe somebody finds the solution for breaking with the physics laws. But I remember when I was working at CERN, it was we were measuring the nanosecond and the speed of at the speed of lights, the neutrinos. So finally, it looks like we couldn't beat the speed of light. So yeah, it's difficult to beat physics.
Is that any comments on the low elevation angle problem, and is that the laws of physics, and it's just going to be one of those things that we'll have to deal with?
Well, yes, mostly, I would say. There's no easy way around it. So, I mean, after 60 degrees, with the scan angle dropping and the cosine of that, the power dropping by the cosine of that angle, it becomes very difficult to maintain the gain to make that connection. So, what you can do, of course, is do conformal antennas, which have some form of dome-like shape, which could add to that scan angle. So we have in the past looked at designs that could go up to 75, 80, even higher degrees of scan angle by adding some sort of form factor to the antenna itself. So there are possible solutions, but we don't see this as a key requirement for the majority of the use cases. And in those cases where those extreme scan angles are required, I think parabolics can continue to play a role, particularly sort of geo and high latitudes. This is where they probably still will have a use case. But for most other use cases, such high scan angles we don't believe will be required. We've looked at some different scenarios in different regions, and for 85% of use cases, for most of their time, these types of challenges do not exist. So we don't see this as a big obstacle for us. We see this as an exceptional situation.
Does that tend to indicate, though, that for the NGSO systems, the ones that have got more satellites and therefore wherever I am, I can see more satellites, I haven't got to worry about low elevation angles? Does that tend to suggest that the ones with lots more satellites, they're going to block out the stars and the sun and we're never going to be able to see the sky again? That the ones with more satellites are going to be more successful because they're going to have a higher elevation angle on the balance of probabilities for each location?
Sorry, Jeremy, I lost you at the last bit. Could you just repeat the last bit once again?
Yeah, so basically the NGSO systems with lots of satellites, the elevation angle from where I am at any point in the Earth is going to be, I can see more satellites. So the ones with more satellites are going to have less of a problem with lower elevation angles. Is that something that you see as suggesting that the NGSOs with higher numbers of satellites are going to be more successful?
If I may, yes, absolutely, because they will be always almost in the maximum gain. So as more satellites you have, more efficient the antenna is, better performance you get because a higher look angle there is. So in my view, yes, as more satellites there are and higher look angle there is, more performance on the antenna and also higher throughput in many cases of this satellite. So that's the key combination, the LEO with the flat panel antennas. That's big. However, GEO can also benefit of that, and MEO can also benefit of that. So, but it is a technology that will explode and will increase significantly when these new satellites come and they don't bankrupt. So it's something that one needs each other in the ground.
So, Bill, I mean, you probably, I'm asking you a question that you may not know the answer to, but you may have an opinion. Do you think that might be why OneWeb went up from a few hundred satellites to fighting for 40,000 satellites?
Yeah, so clearly there is, we have a very good business connecting to geo satellites, but it does limit the regions that we really have a positive experience. When you look at these LEO providers, as Alvaro says, it benefits all of the flat panels to have more satellites in space because the look angles are going to be more toward boresight than they are toward the horizon. Recognizing that, I think, all of the LEO providers are rethinking their go-to-market strategy to look more toward mobile customers because that's where the money is. And you see even OneWeb before filing for bankruptcy started to shift their focus away from consumer broadband to mobility. And in that world, in many cases, you're talking about providing the first connectivity to a platform and there's no other options. So even with scan losses from a geo satellite, there's still a business case to be made. So I think you are going to see the LEOs launching, and I think they're going to focus on the markets that really are in the sweet spot of flat panels, where there's the ability to make some profit. And then they'll eventually migrate to something less profitable, which is where they originally planned to launch. But I think they've realized that you have to fund your debt, and you've got to repay your investors. So they've refocused.
Yeah, I think that's very true. And I think we're going to deal with that at the second webinar in a couple of weeks' time. Keith, have you got a view on the issues that we raised about the number of satellites? The ones with the higher number of satellites are going to be more successful on the NGSO market?
Well, I believe that both SpaceX, OneWeb, and Telesat LEO, if you study their plans, there'll always be one or more, at least two satellites visible at any time at almost any latitude, which is exactly as the others have pointed out, and I agree wholeheartedly. The match made in heaven is the flat panel that's limited to about plus or minus 45-degree scan angle, and the non-geo constellations, particularly the LEO, where there'll be higher numbers of satellites. As long as the MEO are in an equatorial orbit, they sort of have the same challenge as GEO, as needing lower look angles at higher latitudes. So yeah, I think that's the application. If you restrict your electronic scan to 45 plus or minus, that goes a long way to mitigate all the variable performance questions about flat panels.
Jeremy, I would inject. I don't think you have to be the biggest constellation to be successful. We're seeing some of the smaller LEO operators like Kepler finding a niche for a limited number of LEO satellites. So, if you're smart about your business model, you can find a path to success that doesn't necessarily have to be the largest to be successful.
By the way, we're getting a few quite technical questions about off-axis response and things. I think, and for the other questions that we don't deal with during the course of the webinar, there will be they sent off to the panelists, and they'll be responding hopefully in the next few days to those. There are obviously going to be questions that we won't have time to look into. Let's just turn the price a little bit. Are we talking $50, $500, $5,000? Esat, what are your products going to be priced at, do you think?
So, I mean, we've already announced to the market last month what our first product is going to be like. We've put the data sheets for our first product online, and we've also announced that what the price will be. So for the first product, we're calling it a LEO and MEO antenna. So it's basically an NGSO antenna. It will have a G over T of about 10.8 and an ERP of around 45. That's the equivalent roughly of a 65 centimeter dish antenna, for those who are wondering about what's that in comparison to a parabolic. And we've announced the price for the antenna to be 1,500 euros. So we're putting a markdown of what we think we can achieve. We think this is a huge game changer. It is a phased array technology. Phased arrays traditionally have been priced in the tens of thousands, if not hundreds of thousands. So we do believe it's possible to bring this down. Now, the enterprise antenna, we're calling it a small enterprise antenna at 1,500. Could we see a consumer antenna under 1,000? We think it's possible. We think that's going to be the future. How much below 1,000, we'll have to see. That's a hard one to predict. The $500 antenna, maybe I can see that being possible. A number of things need to go right, but it would be madness to try to declare that this is definitely going to happen. But I think we've already put the mark down of showing what a small enterprise antenna, which is kind of a large consumer antenna, can be built and sold at 1,500 euros. So I think already. This will be a game changer for the industry, and this will be a key enabler in helping spread the use of the NGSOs, the LEO satellites usages around the world.
So what do I get for my $1,500? Is it soup to nuts, or do I need to add batteries? Do I need to add something or other? What do I get for my 1,500? Can you hear me on that one?
I unfortunately missed your counter question.
Oh, sorry, my supplementary was relating to what do I get for my 1,500 euros? Do I have to buy anything else, or do I just plug it into my laptop and that's the end of it?
No, I mean that is the antenna price. I mean the LNB and the buck, not the LNB, the buck and the modem are extra. I mean at the moment we've estimated that as an additional 1,000. That's at this stage not part of our own development. We're not building modems. We're not building bucks. We think the ones existing on the market are plenty good. So our idea is to plug into what's already there in terms of those technologies and provides the bit that's been missing until now, which is the antenna component. So combined, the terminal cost, what you would need would be around 2,500. This is what we're estimating for a small enterprise antenna.
How many would I have to order to get to that price? I'm an NGSO, Rose Sat, and how many do I have to order? 1,000, a million?
No, I mean, this is one of the advantages of our technology. I mean, we are using liquid crystal phase array technology. This was developed at the TU Darmstadt by two of my co-founders, Professor Jacobi, who originated the whole space of liquid crystal RF engineering, and our co-founder, Dr. Karabey. And they basically have designed this technology so that it is able to work as a phase array antenna. And the gain of it, it depends, of course, on the size of the panel you're using. So how many of these, you will need to get, it depends, of course, on the user requirements. But in terms of what volume of cell you would need to reach it, because we're piggybacking on the back of production already that's there for display technology, we can reuse existing display technology production capabilities. And we've experimented with our production techniques to show that with only a minor change in production capability, they can produce our antenna. So we think we can already in the first, 10,000 volume, the first 10,000, maybe even the first 1,000 reach those values. So it's not a question of selling 1 million and the millionth will cost 1,500. It's already the first thousands that we're selling will be priced there. And then later they might even go lower. This is why I think the consumer antenna, at 500 is not fantasy. It's not a walk in the park, but there is a pathway there that we can see over perhaps 5-year period to get us there. But the current one we're pitching is enterprise antenna for enterprise use, and 1,500 is already the price that the first buyers will get, not the millionth customer.
So Bill, I mean, Kymeta was also looking at, I think, liquid crystal displays and TV displays and metamaterials. Could you just give us a standing on one leg description of what metamaterials are and why they're so special, and why they're useful to you and why they're going to make it a game changer for you?
Sure. I'm probably not the right person to answer technical questions, but I'll give it a shot. We use liquid crystal. Our antennas are passive, meaning we use liquid crystal to form the beam and do the identifying the phase at which the RF is being pushed through. We use the display lines that ESAT's talking about, but we've been producing them for 2 years. And the antenna is one thing, but the terminal's another. And frankly, the terminal's what people want to have, because without the RF side without the RF pieces on the back of your antenna, you have nothing. We have not seen one of the challenges in the industry is that folks that make the RF components aren't built for scale. And they're certainly not as cheap as everybody hopes. So part of being successful in this flat panel industry is we've got to bring the rest of the ecosystem along. If you were to ask a buck manufacturer today to give you 10,000 bucks, they will tell you they can't make them. They've never made that many ever, and they certainly can't make them at the cost that some people project. So, but cost is, from our perspective, one of the most critical elements to make satellite relevant. So every day we wake up trying to figure out how to lower the cost to manufacture the antennas. We use the same display lines probably that Alcan is contemplating using. We have been buying terminal components for 2 years and buying them at volumes. It's going to take this group effort to really get down to the price points that everybody's hoping for, Jeremy. And it's not just the folks on the panel. We've got to bring the rest of the ecosystem along. I mean, cabling is expensive, you name it. So, but what we're trying to do is we're trying to drive down to the prices that everybody talked about. It's certainly not easy. We're announcing in August, as an example, if we're also a service provider. If you take our service for a multi-year contract, we will provide you the antenna at no cost. So that's definitely the direction that the industry's heading. It's a heavy lift, and many folks have to make it happen, not just the antenna manufacturers. And ultimately, like I said, all the consumers, all these new consumers, these new enabled markets, they want something that's really easy to understand. So I think we've sold maybe 1% of our sales have been antenna only, where 99% of our sales have been terminals. And of that, probably 80% of those are terminals with services attached. These are not folks that are used to buying satellite capacity. So you've got to bring the whole package. That's what we've experienced.
So Keith, moving on slightly technical to power and heat. There have been quite a few questions about that. What about power consumption? How important is it? Is it a problem when one's looking at heat as well? Are those issues that are keeping you up at night?
Those are certainly some of the key things you've hit on with our approach. So unlike the metamaterials or the liquid crystal approach, we're this day using silicon beamforming chips, which have really good advantage in lowering insertion losses, and that the amplifiers, both transmit and receive, are immediately beneath the radiating elements. So the benefit of that is you'll get the best G over T for a given physical aperture size of any of the approaches. But the downside, as you just hit on, is power consumption, which can be probably prohibitive for certain applications. It really depends on how much power is available on the platform.
So what's the power limitation? Are we talking about drones here? Or, I mean, if I've got a terminal at home, I mean, my power consumption is not going to be too much of a problem. Similarly, if I'm on a ship, is that right? Or are we, where are the areas in the market where the power is going to be a problem?
Well, in the dismounted, Warrior case, a man pack, that's going to be a problem because they're running off of batteries typically. So I have very short battery life. Aircraft and ground vehicles, I don't think will be too much of a concern, but it is a consideration that has to be taken into account because we're talking about several hundred watts typically for a small terminal, which is higher than a normal terminal. But the efficiency on transmit and receive will also help level the playing field, in that with a passive antenna, you'll need a bigger buck, which is going to also take more power to have the equivalent erg. So it's not totally one-sided as far as power consumption.
But by passive antenna, are you talking about receive only there?
Well, I break the categories into active and passive electronically steered antennas. And passive has basically a conventional buck and L&B feeding a corporate manifold feeding a radiating aperture. And it's the corporate manifold that has the losses in it that hurt ERP and G over T. Whereas we're doing this active antenna, which puts the amplifiers right behind the elements. Every element has its own LNA and power amp.
So Alvaro, I mean, you're not in the manufacturing business, so you're looking at this from an outsider's point of view to a certain extent. And what do you see the major? We've looked at the pros. What do you think the major problems are going to be, and the major con areas? But con, I mean, not confidence tricksters, but as a pros and cons.
So there is a pro that it's absolutely big one, which is the flatness for beauty in jets and things like that, the flatness for planes, the lightweight, it is the capability of manufacturing faster, which is a big plus. And also we have the adjacent satellite interference, the crossfall, the saturation, how modem or terminal and antenna are plugged together, unified solution, heating and multiple scenarios, the look angle, and the way of activation, provisioning, etc., and link budgeting that is different. So it is. There are many challenges, but also what I wanted to mention is that I fully agree with Bill, because all the industry, whether it's antennas, whether it's modems, whether it's anything, it's going to service. So I highly believe that going to service is mandatory for most of the companies. In our case, in doing software development, we have increased significantly all the service, because now with COVID-19 coming, it is the way to do business, or that's how we are saying it. So we not only have the flat panel antenna challenges, we also have the COVID-19 and different LEO instability challenges. So it is not only technical, there is also economical. So, and instability. So in that regard, most of the industry is going to service. So this is really a right message that I have here, and I'm picking up here.
Right, but in terms of the downside, where do you see the major problems?
In terms of technical, you mean, or pricing?
Any of the above, yeah. I mean, you know, we've heard all the good bits. What about the not so good bits?
So the flat panel antenna is creating a big adjacent satellite interference. So as it is flat, the beam is wider, so less effective and wider. So it affects more satellites. Also, it minimizes and mitigates the cross-poly isolation less. There are a few software techniques that you can apply, but at the end of the day, it's less efficient in the cross-poly isolation and creates a big cross-poly interference. So as more power you transmit, more interference you get in other satellite transmissions. As less savvy the installer, more interference you get. So it is like a parabolic, but in that case, wider. So this is a big difficulty. Also, as the gain is not stable, the link budget is not the same. So you cannot apply, for example, we have a link budget tool tailor-made for flat panel antennas, because this is something very different to doing a parabolic antenna, because depending on the look angle, you get more gain or less. And this is something that we have built for flat panel antenna providers, service providers, as well as antenna manufacturers. So this is completely tailor-made in that kind of requirements, because it's different, it's new. So whatever you did before, it's not applicable.
So it's a link budget, Jim, but not as we know it. Is that right? I mean, basically, it's a different ball game for link budgets for flat antennas than for parabolics.
Correct.
Right. So, Esat, going back to Alvaro's comment about adjacent satellite interference and cross-pole and problems there, is that something that you're aware of, and obviously you're aware of, but like, no, we've sold all of this, or is it going to be continuing to be a pain in your side?
I mean, yes, we have considered, and no, we don't think it's a problem. It's a challenge, of course. I mean, all antenna design is a challenge. Nothing is a walk in the park. It's engineering, which is about trade-offs. in design parameters. But we are able to do beam forming, which is, enables us to then dynamically manage the side lobes of our antennas. And in a sense, that's the big worry about interference, of course, is that the beam, the way it's structured, could, when you're pointing at one satellite, can interfere with another satellite. This is where I think flat panels actually have an advantage over parabolic antennas, because we can do beam forming and we can dynamically control this, both the amplitude and the phase of the signal. So we don't see this as a problem. Cross polarization as well. We have reached levels which are currently acceptable with existing satellite constellations, NGSOs, and we're working to improve that even further in case in the future higher demands will be made by the new NGSO. So I don't think that's a problem. But I briefly want to just touch upon, passive technology, I should mention, which is what our antenna is. You can receive and transmit with a passive antenna. So it's not limited to receive. It's all about the antenna is basically something that points the beam in a direction. But the power of the transmit comes from the buck, so you don't need amplifiers that. And the receive side, because of our unique topography of our antenna, we don't need any amplifiers at any of the radiating element levels. We only need an LMB at the end. So passiveness is not an obstacle. It's a huge advantage because of power consumption. Any of the active solutions out there, they require thousands of watts, 1,000 watts or more to make their antennas work. We can make our antenna work with less than 100 watts, even less than 50, depending on how you count the wattage, whether it's just the antenna or some of the other components that's involved there. So power consumption, we think, will be a huge differentiator in this market between flat panel antennas, which are maybe driven by traditional IC technology or ASIC technology, and flat panel antennas like us, which are based on passive technology. And then maybe just to touch upon Bill's comments, our technologies are not the same. So their experience with their display manufacturer does not reflect on ours. They have a more complicated design than ours. Ours does not require any big workarounds. We have reached, in a sense, the thinness of the antenna components, which is parallel to the display thinness. That's a huge advantage that we have. And secondly, the number of elements that our antenna has is much less than their technology requires. We know their technology very well because the technology also originated back in the TU Darmstadt 20 years ago. So it's a technology we're very familiar with, but its shortcomings that is the bandwidth is limited. Ours is not. Ours is a phased array antenna, so it's no gimmicks. It's no simulations. It's no, almost like phased arrays, or it behaves. It is a phased array antenna, a passive antenna, which has the performance of similar sized phased array antennas out there. But it does this at a cost point, which is 10x to 50x less than what the ASIC-based ones does, and the power consumption is 10x to 30x, depends again how you calculate it, less than what the other technologies are doing. All flat panel antennas are not the same. I think maybe this is another opportunity to underline that point.
Bill, yeah, is that your feeling too, or are you listening to that thinking, well, not quite what I would say? I'm being a bit tendentious there, but what's your view?
Well, clearly, I think I started by saying that all flat panels are not the same. So we're all different to some degree. I will say that what we thought when we start, we've been around for 8 years, and for 6 of those years, we were very ambitious and thought that our PowerPoints would turn into reality, but not until we started to manufacture and put hundreds and thousands of units in the field did we realize what reality was. So hats off to all the folks that are still optimistic they're gonna break the mold, but actually building products and putting them in the field is a long way from a theoretical PowerPoint, my perspective. I do agree that that there is a fundamental difference between passive and active antennas. In the world that we sell our antennas today around land mobility, parabolic, mechanically steered gimbal dishes and phased array antennas are not even being considered. You cannot put a antenna on a vehicle and require 1,000 watts of power. It's a non-starter. And you cannot put a mechanically steered dish on top of a land vehicle. So I think there's a huge advantage for land mobility for the passive antennas, strictly because of the power consumption issue. And then clearly cost is going to become the thing that separates us from a niche business and a business that's relative to the masses. So we have to drive the cost down, and it's going to come from us. It's going to come from the satellite operators and the cost of a megahertz, and it's going to come from the other component manufacturers in the ecosystem. When all that comes together, then we have we have an opportunity to become a relevant, I would say, mainstream in the conversations around connectivity.
We're running out of time, but Keith, then just a 1-minute response, if you want, on the adjacent satellite cross-pole interference issues. All seems a bit dodgy to me.
Well, a lot of those issues can be managed with EIRP spectral density limitations to a great extent. Of course, that does potentially drive up occupied bandwidth over the satellite or operating costs. Back to the power consumption question, and my comments about insertion losses are geared mainly towards Ka band. I'll just want to comment Ku band, which a lot of people are coming up to products with initially, is a much more solvable problem, and the passive arrays make sense. But it's not linear. The losses just don't double for Ka band. They go up by a factor of 3 or 4. So I've been looking at Ka band primarily, and the losses are really extravagant there and punitive.
So, I had a question on my list which I hadn't asked before, and I just need to perhaps get it in there, and I need a 10-second response from each of you. F flat plate antennas, okay, all frequency bands. Keith, you just said by the time it gets to Ka band, it's a problem. Is it going to be only C and Ku, or what? Keith, 10 seconds from you.
Well, I think you'll see Ku initially, but we're working on Ka.
Essa?
First product is Ka, later Ku will follow.
So Ku is more difficult than Ka for your
Not more difficult, no. It's the same difficulty, but our first customer was a Ka customer, SES, and so this is what we focused on.
Bill?
Yeah, our antenna in the field today is a Ku antenna, and we have a Ka antenna under development, and potentially higher frequencies in the future.
Is that because business reasons why you went for Ku first, or were technical?
No, it was business. I mean, it was a deeper sea. I mean, Ka didn't exist 7 or 8 years ago to any extent that, so we focused on the place where we could actually sell antennas. That's why we started with Ku.
Alvaro, are we going to go up to QV band on these, or is there a reason why it gets more difficult as you go up in frequency? 10 seconds.
We do software for all, so it is. We are seeing most of the bands being utilized. Q and V a little less, absolutely, but Ka and Ku much more popular. But antenna manufacturers always choose one to start and then go for the second one. So it makes no sense already having the technology and not looking to a different band. You will have a lot to utilize, but you will need to adapt in many cases. So, but again, to us, we have products that covers all.
Gentlemen, thank you very much indeed for your responses. Ladies and gentlemen, the audience, thank you for your time and attention. Thanks to Kencast for sponsoring and for GVF for organising it. There's going to be a follow-up webinar in 2 weeks' time, Thursday, the 13th of August, same time, being hosted by Stefan Schnarr from Euroconsult, with speakers from OneWeb, Isotropic, ThinCom, the GVF training organisation, and from Kratos. We hope you'll join. For those questions that we haven't answered, I think the GVF is going to organise for the panellists to respond to those in the next few days. Hope you have a great day and stay safe, as they say, and we'll look forward to seeing you in 2 weeks' time. Thanks very much from London, and goodbye.